Hello, this is Surud Reddy from University of Florida. I'm a graduate student at Computer Science Department. So today we are going to talk about implementation and analysis of classification algorithms in the context of sentiment analysis. So what are the different classification problems we can face? So typically we can put them in binary classification, multi-class classification, multi-label classification, and imbalance classification. So coming to binary classification, uh, we just have to decide between two things, where an email is a spam or not a spam, when some customer is going to churn or not churn, or will he buy it or not, something like that. So when it comes to multi-class classification, you need to classify uh, pictures into if it is a face or a plant species, or you need to put it into multiple buckets. So that is with multi-class classification. And when it comes to multi-label classification, you have a in a single set, you might like in a single sample, you might have to classify into different cases. It might be part of three or four cases. Say you have a photo with a dog, a thing, and a person. So you have all the three labels on the photo. So that is multi-level classification. And coming to imbalance classification, there's a huge amount of data on what is proper, and there is like if though you have a binary classification there, uh, there's a huge quantity on one classification, and I mean one type, and there is just a small quantity on the other type. So how do we deal that kind of classification? So coming to what is sentiment analysis, why do we do it? So we have to trace back to, let's say, like this is not something new. Basically, what a survey does is what a sentiment analysis does in 21st century. So what does a survey do? Survey says you're good at something, bad at something, or you're great at something, or do people love you, whether it be a product, service, or a company, or a brand, or whatever. So just just digitizing it doesn't make it easy or like get some new data, though it has been a trend. The survey is being digitized, that is for just convenience purposes. But what exactly sentiment analysis does is, like, if a group is talking about a brand, or let's say even a government, so like, how does that, how is it faring, good, bad, well? So this might not come up in a survey. So it's like macroeconomics, where you you look at the whole data and say this is the trend that's happening. So how do we get this data? So these are the this is where social media kicks in, and then you have a lot of data to study on, and you do have a context there. So that is how it is done. So we know what is sentiment analysis, but how do we do it? That we don't know. So since we talked about classification problem, now we look at which classification problem it falls into. So before that, uh, we can say like application, yeah, about the classification problem. So it falls into, right now, you can have it in different areas, like you can have a multi-class and all. So today, for our project, we are dealing with a binary classification. So we'll show you about that. So applications of sentiment analysis. So as I said, it's brand monitoring. Let it be brand monitoring, competitive research, customer service prioritization, product analysis, like how the industry, how the trends are in industry. If you look at IBM Watson, it's a complicated version of sentiment analysis. You can just simply put it as sentiment analysis, but what it does is it does look at data in a certain context and say what is the trend in that certain industry. So types of classification algorithms. So we have naive Bayes, support vector machines, logistic regression, stochastic gradient descent, decision trees, and random forest. So we'll look at it one by one. So naive Bayes, everybody, we must like Bayes theorem is a very common like it's a basic uh, probability concept where you have two independent events, and then if if there is a probability of something happen with a condition, you can predict the other event. Like and if you know the individual probabilities, you can calculate the probability of A happening with condition that B has already happened. When you know the probability of B happening with the condition of A being happened. So major assumption here is independence of features. So here we are talking about each feature we are selecting uh, for our machine learning model. So naive Bayes classification technique is highly scalable. It's useful for large data sets since the computation made are simple, and surprisingly it outperforms sophisticated models. So when it comes to an example for naive Bayes exam, so you can see there is if you the problem here is to whether to play or not. So let it be a tennis game or something. So when it is or maybe it's an indoor something. So yeah, so when it is sunny, it's too sunny, maybe no. So there's some data, and you convert into a frequency table. You extract the features, and then for each feature you calculate probability, conditional probability of playing on that day with that feature as yes or no, and depending on that, we'll try to predict if we can play or not given the climatic conditions. So this is something something similar to what we'll implement. So we'll look at it. So support vector machines. So here we have in this example we have a 2D data where you have points, and then we are trying to classify these points with a hyperplane. So generally, this support vector machine is used for classification and regression analysis. So for n-dimension data, there is an n-1 dimensioned decision boundary. So using these planes, we'll try to predict where, like, we'll try to classify the input. So coming to logistic regression, it is similar to linear regression, but we'll use a sigmoid function to predict if something is to keep the numbers in the range of probability where we use this sigmoid function. So it evaluates probability of things falling into a classification or not. So stochastic gradient descent. So uh, in a gradient descent, we do have we derive on some variable and then equate it to zero to minimize it. So in a similar way, for each feature, we'll do partial derivation and then compute the minimum possible errors. So these coefficients, when used, we should be able to predict. So when so that is stochastic.